Hello, this is Susan Poss, and I'm creating a video to match up with section 9.6. You've been learning how to solve equations, and now you've got some word problems, application problems. And the first type of problem is the distance, rate, time. I'm going to be working distance, rate, time in this video. I'll do another video on cost, another video on interest, and another video on averages. All right, so here's the first example. I took this straight out of your Hawks textbook. A brother and sister leave a family reunion at the same time and drive their cars in opposite directions. The brother's speed is 50 miles per hour. The sister's speed is 65 miles per hour. When will they be 460 miles apart? Okay, so the first thing I want to remind you about is how to identify where these numbers go. So if you're looking at rate is always in terms of something like miles per hour, feet per second, meters per minute. So it's a linear compared to a unit of time. So those are always the rates. Time, of course, can be in hours, seconds, minutes, and I suppose there are some other measures of time that you could be using, but we will stick with those. And then, of course, distance can be in miles, can be in feet, can be in meters, can be in kilometers, some sort of linear measure. So that will help you as you identify the numbers. Notice that I have left the formula, rate times time equals distance. When I copied this problem, that becomes the template or the guide for the chart. I would highly recommend that you create a chart when you work these problems. It's a really good way to get yourself organized and sort of keeps the information from being so overwhelming. And I would also recommend that you do a sketch. So I'm going to start with a sketch. These people are at a reunion, and the reunion has ended, and the sister goes off in one direction, and the brother goes off in the opposite direction. The sister's rate or speed is 65 miles per hour. Maybe she's on the interstate. His rate or speed is averaging at about 50 miles per hour, so perhaps he's on some two-lane roads. So they start in the middle, they go in opposite directions, and at some point in time, they're just traveling along, getting further and further apart. At some moment in time, this distance will clock in at 460 miles. All right, so that sort of helps me think about what's going on here. So what I'd like to do here is we're dealing with two people. So you see on my chart I've created two rows. In one row I'm going to put the brother's information, and the other row I'm going to put the sister's information. So the brother under rate, first column, is 50 miles per hour. Sister's rate is 65 miles per hour. You cannot put the 460 out there for the distance because neither one of them travels 460 miles. They travel a total of 460 miles. So we don't really know how far the brother goes or how far the sister goes. But there is something here that's very important. I always like to go to the last sentence or wherever the question mark is to see what I'm looking for. In this case, I'm looking for when. And when equates to time. So let me think about the time. Does either one travel more time than the other travels? They start at the same moment, and then the 460 distance, total distance apart, is reached at the same moment. So I'm going to use the variable t That's what I'm looking for. When. I'm going to use the same variable t for both of them because they do travel the same amount of time. They start at the same moment and then they reach that 460 total at the same moment. Now this is typical of these problems. You fill in 2 columns and then you use those 2 columns to generate the third column. So I'm going to let the formula work for me. It's rate times time equals distance. So I'm going to do rate times time equals distance. Rate times time equals distance. So I have 2 expressions for distance now. One for the brother, 50t, and one for the sister, 65t. All right, so here's the last thing that I need to put together. I need the equation now. And this is where my drawing helps me. So the brother's distance added to the sister's distance. And if you have to write it down in words like this, go ahead and do that. That will help you sometimes to get the equation just by writing out the words. And then you can put it into the symbols. So the brother's distance is 50t. You can see that up here. Here's distance, and here's the brother's distance. The sister's distance is 65t, and the total distance is 460 miles. Okay, so now it's just a matter of adding 50t to 65t, dividing by 115 on both sides. Notice that cancels out and the variable t remains, and this comes out to 4 hours. All right, so that's my answer. That's when in 4 hours they will be 460 miles apart. Let me go back and do a quick little check here to see if it makes common sense. This looking back step to see if it makes sense is always important. So the brother was going 50 miles per hour for 4 hours, so he is now 200 miles out away from the reunion. The sister was averaging 65 miles per hour. She's been traveling for 4 hours. That's 260 miles out, and if you add those back together, whoops, that's not right. You come up with 460 total miles, so that checks. Okay, so I hope that helps you get started. I have one more I'm going to scroll down and work for you. It's a little bit different. Again, I took this out of the Hawks textbook. A motorist averaged 45 miles per hour for the first part of a trip, 54 miles per hour for the last part of the trip. The total trip is 303 miles, and it took 6 hours. What was the time? Here's the question. What was the time for each part? All right, so let me do my little sketch. She started out and went for the first part of the trip, averaging 45 miles per hour. Okay? Stopped, took a break. Second part of the trip, last part of the trip, she was able to average a little bit faster rate, 54 miles per hour. This is the last part of the trip. The total distance that she covers here is 303 miles. So that's my total. And the total time is 6 hours from beginning to end. All right, so there's my sketch to kind of help me get organized. I'm going to come down here to my rate times time equals distance. And again, remember I use that to help me establish what's in the chart. Okay, so I have a first part of the trip, excuse me, and no, they didn't call it a second part, they called it a last part. Last part of the trip. Okay, so the rates are easy. First part of the trip, 45 miles per hour. Second part of the trip, 54 miles per hour. Time was it 6 hours on the first part of the trip? No, it was 6 hours for the whole trip. So I can't come in here with 6 because she went a certain amount of time for the first part, and then she went a different amount of time for the second part of the trip. So for the first part, can I put in a distance of 303? No, because the first part of the trip was not a total of 303. It was, again, first part would have been a little bit different, possibly from the second part. I suppose they could have been equal, but so I'm saying this to say it's real easy just to throw numbers around. You can't do that. So we're looking for the time for each part. Remember I said go to the question to see what you're looking for. You're looking for the time for each part. And you can see I left this in here. They've assigned T to the first part of the trip. And they've assigned 6 subtract T for the second part of the trip. So let me see if I can talk you through that. So if the first part of the trip is 1 hour, then what is 6 minus T? That's 5 hours. If the first part of the trip is 2 hours, then what is 6 minus T? It is 6 minus 2, which is 4 hours. So the total 6 subtract the amount for the first part of the trip identifies the number of hours or minutes for the second part of the trip. All right, so again, remember I said this is typical. You have 2 columns filled in, and you use the template, the formula, for figuring out the third column. So 45 times T gives me the distance for the first part of the trip. Remember, it's rate times time equals distance. And 54 times 6 minus T gives me the distance for the second part of the trip. So now I'm going to write out my words so I can get my equation. So the distance for the first part of the trip added to the distance for the last part of the trip totals up to 303 miles. So the distance, just subbing in here, come to your distance column, and for the distance for the first part of the trip, you see 45T. The distance for the second part of the trip, 54 times 6 minus T equals 303. Now you start doing your solving process. I see a couple of like terms in here, 45T and negative 54T. I'm going to go ahead and combine those. And now I'm going to subtract 324 from both sides. And dividing both sides by negative 9. Don't ever divide by the variable there. You want the variable to remain standing. Oh, what is that? Goodness, I don't like the way that looks. I can't read it. Hold on, that was supposed to be a 21, I think. There we go. 21 divided by negative 9. That gives me a positive, because negative divided by negative is positive. I'm going to reduce both of these by 3. 7/9 hours. No, 7/3. I was right the first time. Dividing each by 3. 7/3 hours. Which is 2 1/3 hours, which is 2 hours and 20 minutes. A third of an hour is 20 minutes. All right, that only gives me one of the answers, because the question was, what was the time for each part? Right, so the second part of the trip is this 6 minus t, which in this case is 6 minus 7/3. T is 7/3. So this is 18/3 minus 7/3, which is 11/3, which is 3 2/3. Yes, 3 2/3 hours, which is 3 hours and 40, 2/3 of an hour is 40 minutes. All right, so the question is, number one, does that add back up to a total of 6 hours? And I'm looking at 20 minutes plus 40 minutes is 60 minutes, so that's an hour. 2 hours plus 3 hours is 5 hours, and this one more hour adds that back up to 60. So if you wanted to go a little further with your check, you could do 45 times t, which was 7/3, and you could do 54 times 11/3. All right, so 3 into 45 is 15, and 7 times 15, I think, is 105. I may have to get my calculator out here in a minute. 3 into 54 is 18 times, and 18 times 11 is 8. 9, 1? I don't know. Hang on. I think that's right. Excuse me, 898. I had it right. Okay, looks like that's right. So does that add back up, first part, second part, distance, does that add back up to 303? So 5 plus 8 is 13, 1 to carry 10, 1 to carry 3. So, you should be able to look back at these and reconcile in your mind that these do, in fact, make sense. Okay, I talked a long time, but I hope that helps.